So we are creating the field symbols. We are understanding the concept of field symbols and how we are using in the OOPS program. OOPS program, we are creating the field symbols. So field symbols is something which will have the variable length of it. Okay, so we'll have a variable length of that particular fields. Okay, so we'll have, I mean, like it's dynamically you can assign the length of the field. That's what we have here. Let me show you that. So let us go for a class, simple class. Okay, so let's say we create something like field symbol, field symbols. This is how we create a field symbols. Okay, so field symbols fs type any class c1 definition and class definition and class. So we have public section data item type I value 5. So this is a variable. This is item type I is a variable, and then we have this. We are defining the static class here. So class, how do we declare a static attributes? How do we declare static attributes or static method is we'll write class hyphen data. So this is an instance. If you write data, this item becomes a default instance attribute, but class hyphen data becomes a static attribute. In this we have onum type I value 10, something like that. Okay, so we are giving this is a static attribute, this is an instance attribute that we are defining. Then we are going ahead with the implementation class. So for if we have the implementation class c1 implementation, we must write class implementation and end class even though we don't have the methods. In fact, like in this program we don't have any methods at all. We just have two declaration parts in the public section. That's it. So then we go ahead with the, this is the implementation part. Field symbols we are declaring this fs any, and then we go for startup selection, and in the startup selection data oref1 oref1 type ref to c1 oref1 type of create object oref1. So create object oref1. Then we have assign oref1 item to fs. So assign. So what are we doing is, now what will happen here, I'll explain you about the field symbols. How the field symbols actually works is what I'll just tell you. See, field symbols will basically have the memory space allocated to it. Okay, so let's say now we are saying assign, create assign orf1 item to fs. Now let me give you an example of this. In this program we are saying assign orf1 num1. Okay, so there is num1. Okay, we are assigning it to orf. We are assigning it to field symbol. Now what exactly happens here is, okay, what exactly happens here is, the moment we assign a variable to a field symbol, the memory of it will be allocated to this. Means if I give num1 equal to num1 is equals to say Prajwal. Okay, if not, okay, in fact, like num1 is a number, right? So yeah, number. So we'll give it as, so item is actually 5. By default it is 5. Okay, so now if I say num1 is equals to 10. Okay, even before, once we assign this, and if we write fs what will be typed is the default value of num. The default value of num which we have declared here in the program would be num is equals to num1 is equals to 5 is already we have initialized is equals to 5. Now both will share the same memory space of the value. So when I say assigned, once num1 is assigned to fs, it means that if we have num1 is equals to 5, okay, and here we have write fs, then 5 will be typed. Now when I say num1 is equals to 10, and when I say write fs, then write fs, then 10 will be typed. Okay, and now again we'll go for fs is equals to 15, and then I write num1, then 15 will be typed. Means whether you assign the value to fs, if you assign the value to fs, it will be updated to num1. If you update the value of num1, it will be updated automatically to fs. So when we say assign, it means that they both will share the same memory space. So whatever you whatever you save in the memory space will be assigned to both the values. Okay, that is the meaning of assigning num1 assigning to fs. This is what is the meaning. Now let's go back to the program. So in this we'll go ahead with fs. So write slash 5 fs. Okay, write 5 fs. Now what will happen here? Fs, this should be, it's not okay, fs. So what will be typed? See, default value of num1, we have to declare num1 here. Okay, we have already defined num1 I underscore num type I value 5. So it's automatically assigning this value is 5. Inum is equals 5. So what we have done, oref1 inum to assign oref1 inum means this is a variable to fs. Means if when I say write fs, what will be typed? This 5 will be typed because it will have the same memory space. Now then we'll go for assign oref1, no, not oref, c1. We'll go for directly static. We'll go for this class onum to fs. Okay, so what is onum now? Onum value is default value is 10. So when we say write fs, okay, write fs, then what will be typed? Because we have assigned onum to fs, now whatever is the value of onum, that will be typed here. Okay, this is what we have. First let us understand this, then we'll go ahead and assign the value to fs. Okay, then we'll see that value. Okay, 5 and 10 is typed. We are writing the same fs and we are not assigning the value to fs, but since we have assigned the variable, that variable value will be automatically updated to fs. Okay, so what are we doing is c inum. So we are typing the c inum. Is it c inum or c onum? C onum, because this is C onum. So what are we doing now? Since see, remember, see here, observe carefully. 26th line we have already assigned the onum. Okay, C1 we have assigned C1 onum to FS. Means C1 onum is assigned linked to FS. Now both will share the same memory space. Now what are we doing? FS is equals to 15. So obviously this value also will become 15. Let's see that. So when you say this 15 is typed, see here, 15 is typed. Okay, why are we not getting this? Here we have written /5. No? Here we didn't write the /5. That's the reason it was starting before. So this is what we have. Okay, so whether you assign the value to the field symbol, that will be updated to the field. If you update the value to the field, then it will be updated to the field symbol. That's the concept of field symbol. Field symbol will always does, in fact, in short, if you want to tell, field symbol does not have in its own memory. It will be by default, it should be assigned to some variable, and that will be that variable memory is used. So we'll understand the concept of static attributes. Static attributes. Now, in the what exactly are static attributes? Static attributes are those which can be directly called from the program, and it will not change its values even in course of time. Okay, let me just give you an example. So let's take the let's consider one simple class. So we have class C1, definition, and class. So public section, we'll go with public section. Class hyphen data. This is how you define the static class, static attributes, right? So we'll have num type I, methods say m1, methods m1. So we need to do the implementation for method m1. Class C1 implementation and class. So we do have method m1 and method num is equals to num plus 1. Num is equals to num plus 1. Write num. Okay, so I'll just explain you this. We're just writing this num. This num is some value. So by default it will have 0 because it's an integer, and we are saying num is equals to num plus 1, right? Num. So we'll see this. Now what we want to do is, see, next time when it comes into it, class, if it's a class, I mean static attribute, it will carry forward. I'll explain you that. So the significance of that static class is, static attribute is what I'll explain you. Startup selection C1 num is equals to 3. Write C1 num. Now we are saying C of C1 of num, that num whatever we have is equals to 3. We are writing it default as 3. Then we are writing C1 is equals to num. Now we'll go for data oref1 type ref2 type ref2 C1 oref2 type ref2 C1. Create object oref1 oref2. Call method oref1 m1. Call method oref1 m1. This is what we have. So now it's like create object oref1 and oref2. So call method oref1 oref2. So now what are we doing here is, now we are creating two objects. Okay, one is oref1 and one is oref2, and we are seeing how the we are saying create object, and we are calling it first time, and we are calling it second time. So when you're calling it second time, what will happen here is it will update the data. Okay, see, first what we are doing, we are first writing the value of c1 num. What will be happening? 3 will be typed. Then it will go and call the m1. In m1, what was the value of num? 3. 3 plus 1, 4. It will come back. Okay, it will calculate it and come back. And then here write statement is there now, so it will type 4. Then again it will come back. This will call to the next to ref2, and then here it will calculate, and it will be updated with one more. So if you see here 3, 4, 5 is typed. Let us now consider a instance attribute. Now you'll see the difference. Okay, let us take into consideration immediately an instance attribute. Instance attribute will not be taken forward from one object to another object. Okay, let me take an example of that. Data, some this is I num. This is instance num. Okay, type I, instance num. Okay, now here we'll go for, here also we'll go for I num is equals to I num plus 10. Okay, and say write 5 inum. Right? This is an instance one. The second one is the instance one. First one is the static one. So let's see how it will change. Now when I'm saying, okay, so when I'm saying this, first time m1 is there, second time m2 is there. So from object to object it is incrementing, it is carrying forward. But how it will reflect is, see, if you have this, I'll go for, so here 10, 5 and 10. 10, 5 and 10. Or I'll go for this one only. It will be easy. So 1. And what is the default value we are giving? Default value. Okay, default value is 0 actually. So I'll go for, so we have 5 here. Default value is 5. Then we are making 5. Here we'll write after create object, right? OREF1 inum is equals to 5. So if we here we have 6, 5, and again it is coming back to 1. So what is happening here is, what I'm trying to tell you here is that the value of a particular variable will not be carried forward, if at all, if it is declared in the instance. From one object to another object, it will not carry forward that value. So in case of the static attribute, it will carry forward. So it will be like, so we have this as, okay, let me give another one. So we are calling this method m1. It is going ahead like that. M2. We're calling this M2. Call method body of 1 M2. Call method body of 2 and so if you're getting here 1, so we just say skip 5. So inum plus 1. See, basically inum plus 1 means when it is printing this value. Okay, when it is giving this uh, otherwise I'll go for this instance attribute. This will be more easy. Right, static attribute. So now here, this I am static attribute is first 3 is typed. Okay, then I am static attribute 4, 5. But here I'm instance attribute. It is 6. Second time what is being printed 1. Why is it so? Because it's initialized to 0. The instance attribute will be automatically initialized to 0. When it is again coming back next time, when it is calling this M2, it goes, and when it goes, the what is the default value of inum 0. It will be default value 0. Okay, let's understand this now in the backend. We are understanding the same thing in the backend. So we are just understanding the difference between the static attribute and instance attribute. Now what is inum equal to this? Inum is equals to 0. Okay, inum is equals to 0. Now we'll go ahead with execute this, and inum has become 1 now. Now m1, not m1. We'll go ahead. Okay, we'll go ahead with this. What is num value? Num value is 3. Default num value is 3. And what is inum value? Inum value is 5. Okay, so now it will come here, execute. Now inum value has become 4. Then it will come back into the program. It will get enter this. See, inum value is initialized to 0. See, so second time when it is coming back to the class, inum value, that is the instance attribute value, is becoming 0. But for static attribute it is still continuing. Okay, now it will call the m2. When we go to m2, so m2, because in the initial it was initialized to 5 in the program, so it becomes 6. And now once it comes back, see, inum value has become 0. Every time the instance attribute value is been updated to 0, but the static attribute is carried forward. Next value is carried forward. This is what we have. So if we execute this, we'll get this as 3, 4, 5. And instance attribute, first it's coming 6 because we have initialized the value as 5, and then we are updating it with plus 1. So it will be 6. But for am instance attribute will be only 1. So we'll go ahead with the parameters concept in the methods parameters concept. So let's understand the parameters concept with the a simple program here. And, we have a lot of options in which we can go with the parameters. We'll go with the simple one now. Okay, let's say we'll take the class C1 definition. Obviously, that's end class. So in this we have the public section. In the public section, we'll declare data num type I value 5. Num type I value 5, and we'll go for methods m1 importing so I1 type I type I. Okay. I1 means this is input. Okay, this is the input. Okay, so we are using import parameter here for the class C1 implementation end class. So we'll go for method m1 end method. We have to write the implementation, right? End method. So in this we'll write simply num is equals to num into I1. Okay, so num into I1. So that's the input field. We are passing this value. So then we are going to go ahead with write num is equals to 5. Then startup selection data O1 type ref to C1 create object O1. Now we'll see what are the different ways in which we can call the method with one input parameter. So we'll have different ways of how do we call it. So call method O1 M1 exporting I1 is equals to 4. Means what are we doing? We are giving value of 4 to I1. So I1 is passed here. So what is the I1 value? When it is going into M1 I1 value we have initialized as 4. So automatically that 4 will be passed into the method because we are exporting it into the method. So num is equals to what? Num is equals to 5. Num is 5. So 5 into 4 is 20. So num value will become 20. So it will be written as 20 now. Okay. So that is one way of calling it. Okay. Then we'll go for call method O1 M1. Okay. Here bracket space I1 equal to 5 and space. So here we have to write without space. We have to start here after M1 without space, and inside we have to give a space here, and then full stop last. Okay. So this is another way of declaring. So we can write it like this: exporting I1 is equals to 4, or we can write like this: I1 is equals to 5 in the bracket, or we can also write like this: call method O1 M1 6. So these are the three ways in which we can pass the parameters without writing. See, once upon a time in the previous versions, this would have not worked, but right now this is the way we can write it in the shortcut method. If we have only one export parameter, we can simply write like this. Instead of writing exporting I1 is equals to 4, we can write simply brackets and 6. But here I1 is equals to 5. This is the ideal one because it will avoid confusion of for to which value we are passing it. Okay, activate this. It will be 20, 25, 30. So it's like the first time we are passing this 4. 4 into 5 is 20. And here we are passing the value as 5. 5 into 5 is 25. And here we are passing the value as 6. 6 into 5 is 30. So that is those are the values which have been printed here in the 20, 30, 30. Okay, so these are the ways in which we can pass the parameters into a method. So we'll go for static method now. Now let's create a simple program with a static method. Test class definition and class test class implementation and class. We have public section, class methods, test method. Okay, so this is test method. Okay, we are defining class methods. So just like we have defined class attributes, we have defined class methods. It's like class hyphen data we have written, right, in the previous program. So now we are writing is class hyphen methods. So the class hyphen methods, and then we have here method, method, test method, and method. So in this we can just write num is equals to 5. Start with class call method. We can directly call the method, we will directly call the static method from the class. So we have test class, test method, test class, test method. So this is what we have. So we need not declare the object and all. We can directly call the method from the class. We have fashion. So what happens is we go and call the test method. Num is equal to 5 and write num. That's it. Simple one. Simple. Just have this. So we're just making use of, we are understanding how to declare a class method, that is static method, and how to call it. That's it. Simple program to understand that. So we're going ahead with the methods exceptions. we have class C1. We'll see how to use the exceptions in this program. So definition and class methods and one. So we need to write this in the public section. Methods and one, and we'll write all the exporting, importing, all we'll use. So importing n1 type I, exporting n2 type I, exceptions e1, exceptions e1. So this is what these are the values that we are passing to the m1 method m1. Now obviously we have to go for the class implementation, class c1 implementation, class c1 implementation. So we have the end class, and we have to do the implementation for this class which we have defined here. The method that we have defined, that's a method m1. So we'll write method m1 and method and method. Now in this we'll go ahead with the class. This is like the if n1 say less than or equal less than n1 less than 5, say message I 001 of 00 with value should be greater than or equal to 5, raising even. So raising even. So raising even. This is what we have. Else part in this. Else part. So it's n2 actually. So I need to give this exporting as n2. So that's n1. So if n1 is less than 5, you have to do this. Else part. If n2 is equals to n1 into 5, n2 is equals to n1 into 5. N2 is equals to n1 into 5. So if let's say we have it's less than 5, if n1 is less than 5, you have to raise and message that it should be greater than 5, and raising even. So this is how we write it. So without creating a message class, we can populate the messages in this way. Even in the normal program also we can write like this: message I001 of 00 with value this is a text that we want to populate, raising even. This is how we have to do it. We go ahead with parameters d underscore no type I, startup selection, data o1 type ref to c1, data o1 type ref to c1, create object o1. We have kept the condition now, so we are raising even. So we go ahead with call method obj1 1. Now here whatever we wrote is importing will become exporting here, and whatever we written exporting will become importing here. So we'll go ahead with exporting n1 is equals to p underscore number. P underscore number is the parameter that we are passing here. Okay, and importing again we are capturing the data back to capturing the back into again to p underscore num. So we're taking it into the same field. In fact, we can take back the data into some other field, but we're doing it. So p underscore num, let's say we have given test 10. So 10 will be passed to n1. So then it will be doing all these things, and it will become n2 will become something like n1 into 5. So that will be like say 10 into 5, that's 50, and 50 will be copied back to p underscore num. 50 will be copied back to p underscore num. Exceptions e1 is equals to 1. E1 is equals to 1. So there is this exception here. Now if size of RC is not equal to 0, means if it's not successful. What it means, the size of RC is not equal to 0, it's not successful. Message ID sy msgid, right? Sy hyphen msgty number, sy hyphen msgno. So this right with so we are writing these messages here like sy sy hyphen msgv1 sy hyphen msgv2 sy hyphen msgv3 sy hyphen msgv4 else right. So I will explain this program once again once it's been executed. So let's say we give it as 10, this value is 10, and value the output is 50. So what are we doing here is, if at all, let's assume that we'll give it as less than 5, we'll get as 4. Now it should raise a message. It raises a message that value should be greater than or equal to 5. Okay, so this is what we have. Okay, so let us understand this once again. So what are we doing here is, we are passing a new variable called exceptions. Exceptions is for populating some messages, and what we are doing is, we are writing a logic here saying that message i00100 with value should be greater than or equal to 5. So raising e1. So when e1 is actually the exception which we have declared here, we have the parameters p underscore num type I, startup selection o1 type ref to c1. So create object o1, call method o1 m1. This we have this exporting importing. So exporting, we have n1 is equals to p underscore no, and importing n2 is equals to p underscore no. Now we are passing this value to the n1, and the major criteria for this is, we are using the import and export parameters, and we are doing some calculations internally to in this method m1, and we are also raising an exception e1 is equals to e1 is equals to 1. 1 means, in this size sub r c equal to size sub r t not equal to 0 means exceptions e1. When we say exceptions e1, then size sub r c value will become 1. Okay, and this msgv1 will be by default getting triggered. Okay, let's see this now. Let me set a breakpoint here. It should be activated. Okay, we have activated, executed now. So I'll give this as the value as 5. Okay, 5 into 5, 25 will come. So but what is happening in the backend is what we'll see now. So here p underscore no value is 5. Okay, p underscore no value is 5, and then this n1 value will not get it, because this is inside the method, right? So when we go inside the method, n1 value and n2 value can be seen. So we are just passing this value 5 to this n1. Okay, it comes here. Now n1 value will be 5. N1 value is 5. So it's like, execute this. So it passes, it message is not triggered. Now it will come to this one. So now what is n2? N2 is 5. By default it is 5, and execute this, it becomes 25, and n2 will become 25. Now it will come here, the size sub r c value is 0, so it will not get triggered. This messages will not get triggered. Execute, and you will get this as 20. But let's see, if you take it as 4, what will happen? Then it should get triggered. Less than 5, right? So it gets triggered. So let's see how it will process in the backend. So we'll go for this p underscore no. We have this as 4, and then we'll go ahead with n1. N1 will not get it now. Execute. It will get into the method. N1 is 4. N2 is 4. Okay. Once it's passed, it comes here, and if you see the size sub rc value, size sub rc is 1. Why it has become 1? Because we have given exceptions e1 is equals to 1. So it is raising 1. So if it is 1, so this is sy-msgv1. So if we have 1, we can raise this. If we have 2, we can maintain one more message that we will do now. Okay, so for sy-msg3, if you have any other value, and that exception should be raised. Okay, so we can raise exceptions even equal to 1. We'll write another call method in which we'll write the exceptions e2. Okay, and then we'll change that. Okay, that also we can go ahead. Okay? We can go ahead with the exception e2 as well. E2. Okay, so let's do that. Now we'll go ahead with exceptions even. So exceptions even, exceptions e2. Now here else if part, some other condition. Okay, we are checking it for some other n1 is greater than 50 or greater than 100. Okay, it should raise this one. Message I002 of 00 with value should be less than 100, raising e2. E2 raising e2. Now we'll go with here e2 is equals to 2. E1 is equals to 1, e2 is equals to 2. So now this sy-msgv2 gets triggered at the time when we are writing a value greater than 100. And then what will happen if msgv2 is triggered? Then automatically it will go ahead and trigger the second message. The second message is this one. Okay, raising e2. We have written here, right? Raising e2. So if this message gets populated, it will raise the e2. So if it raises e2, then it will go here into this. Okay, so let's again start the program from the beginning. Let's start the understanding the program. Let's create a breakpoint here. Let's set a breakpoint. Let's set a breakpoint here. Execute. Let's say we have it as 101, 101. Execute. Now the program has started executing. So first it comes here because this is the start of the program. So this is the first 31st line is the first line it will get triggered in the program. So if you go for this p underscore no, it's 101. Then we have this as importing n1 is equals to p underscore no. So we have this n1. N1 will not come. Okay. Then we'll go ahead with the next step. It will get into the method. So first statement is not satisfied. Second statement is satisfied. Actually it will come to the messages directly. It will come to the message. Now if you see msgv, we have value should be less than 100. But msgv2 e2 is raised now. So if we go here, enter a valid value, is equal 2 means this sy-msgv2 has to get triggered actually. I just need to check the size of our C value because size of our C value should become 2 when we execute that. Now, what is size of our C value? Size of our C value has become 2. That's right. Size of our C value has become 2. But that value has to be updated to sy-msgb2. So for this, the message is not there. That's the reason it is showing up as assign a valid value, something like that. Enter a valid value. So basically that needs to be get triggered. I'll just check that and I'll let you know. So this is like E2. So E2, this MSGV2 has to be assigned, and MSGV2 should be equal to that. So we are giving this sy-msgid type sy-msgty number. So the same way we can also fill it up for the function module as well. For the function also we can have the similar kind of exceptions being raised. Okay, so we can get a lot of such things, like we can get a lot of such examples here. So basically what is happening in the messages, when you double click on it, it will take us to this message class, standard message class 00. 00 is the message class name. We created our own message class starting with Z, right? So this is a standard message class 00 in which we are using this and one and two and means it will be dynamically, we can add the text. So we are adding text as value should be less than 100. So this is the exception which we are raising. So for this, we are going ahead with that one. And now once we execute this, so we have this 10 execute. No, for 10 it doesn't raise that exception. Let me 50. Okay, that exception has to raise means I'll do it as 101, 101. Now it says value should be less than 100. So how it is getting populated is what we'll see now. So in this E2, see when we execute this, oh, I directly clicked on the execute. It should be F5. So we have this. In this, like we'll go ahead with 001. Means that n1 is equals to 11 or 1. Okay. So if we Go for next step. Thus 15, it comes to 15th line. 16th line is satisfied. Then it comes here. Now if you see the size sub RC value, size sub RC value will be 2. Value will be 2. Now if you see the SYMSGV1, SYMSGV1 value should be less than 100 is updated now automatically. So it's automatically updated in this message. When I execute this, value should be less than 100 is coming. Second message is coming.